everyone! Today we are going to be classifying triangles. Look at all of our diagrams here, made up of all different types of triangles. Today we'll be making sure that we can classify triangles by angles and by their sides. So let's just define what this thing called a triangle is. A triangle is a figure formed with three non-collinear points. So a figure formed by three non-collinear points would resemble this little picture that we have right here. And we name this triangle DEF. So you can see that here. We've got an angle E and a vertex E. We've got angle D, vertex D, angle F, vertex F. So basically, the vertex of each angle is a vertex of the triangle. So let's write that here. So after we copy down this definition of a vertex, let's take a look at our diagram here so that we can understand the parts of a triangle. Now, notice the diagram here indicates that this point here is called a vertex. Remember, the vertex of each angle is a vertex of the triangle. So a vertex is a point, and it represents a vertex of the triangle. And inside the two rays that enclose this vertex is the angle. Each side of a triangle is a segment, so we'll remember our segment notation for that as well. Now, usually when we name a triangle, we name the triangle with the three vertices. So notice right here, triangle DEF represents the triangle having vertices D, E, F. So let's write out what all of the parts are of this triangle so that we can better understand what the parts represent. So the sides to triangle DEF will be segment DE, segment EF, and finally segment DF. So since a triangle is made up of three vertices, it will also have three sides. And again, the vertices of this triangle are points D, E, and F. Now, using proper angle notation, the angles of the triangle represent angle D, angle E, and angle F. Now that we are familiar with the terms and the parts of a triangle, let's classify triangles. So if we look at this first triangle, for example, we have different terms for each of these types of triangles. Now notice this angle measurement is 80 degrees, this angle measurement is 60 degrees, and this angle measurement is 40 degrees. Since all of the angles of this triangle are acute angles, we can classify this as an acute triangle. And remember, that is a triangle such that all angles are acute. Now let's look at this next triangle that we have. Notice this angle, although it's an acute angle, and this angle is also acute, we have one angle that is larger than 90 degrees. Therefore, since we have an obtuse angle within the triangle, we actually call the triangle an obtuse triangle. So the rule for an obtuse triangle is that we have one obtuse angle. And then finally, look at this last example that we have. This angle is 60, this angle is 30. We could have different combinations for these too. But the key thing that we want to focus on is that we have one right angle. So the way we can classify this triangle is to call it a right triangle. And again, that is because we have one right angle. So there we have it, the 3 different ways we can classify a triangle based on the angles. So when presented with the angle measures of any triangle, we can classify it either as acute, obtuse, or right triangle. Now let's move on to the next exercise. Notice we want to be able to classify each triangle by the sides as well. So in this first diagram, we see that the sides are not indicated by any lengths that are equal to each other. So if we have a case where all 3 sides are not equal to each other, usually we would indicate this by marking up the sides. So pretend we had 1 slash through this side, and 2 slashes through this side, and 3 slashes through this side. So if we are guaranteed that all 3 sides of this triangle were not congruent, then we would call this type of a triangle a scalene triangle. And again, the rules for classifying this triangle as a scalene triangle are that we do not have congruent sides. So no sides are congruent. Now let's look at this next triangle here. We don't know if this 3rd side is congruent to this side or this side, but remember, when we have the same amount of slashes through segments within a diagram, that's to indicate that the 2 sides are equal to each other. So if we're given that 2 sides at least are congruent to each other within a triangle, then we can classify that type of a triangle as an isosceles triangle. Now let's be careful with the spelling here. I-S-O-S-C-E-L-E-S. An isosceles triangle is one where at least 2 sides are congruent. I'll actually use my congruent symbol. And finally, let's look at this last triangle that we have here. Since it indicates that we have 1 slash through this side, and this side, and this side, then that's telling us that all 3 sides are congruent to each other. If we're guaranteed that all 3 sides are congruent to each other, then we call that type of a triangle an equilateral triangle. So again, let's be careful with our spelling here. I'm going to call that equilateral. E-Q-U-I-L-A-T-E-R-A-L. So again, if all sides are congruent, then it's called an equilateral triangle. So remember, that's when all sides are congruent. Now let's consider the components for this given isosceles triangle X, Y, Z. Now in this diagram, it's indicated that the length of XY is congruent to the length of XZ. So we actually call the sides that are equal to each other in an isosceles triangle the legs. So let's list those here. If they're asking us for the legs of isosceles triangle XYZ, we're going to name the two segments that represent the legs. So that would be segment XY and segment XZ. These are the two legs that are congruent to each other. The base is the side that's not necessarily congruent to the legs. So from this diagram, that would be segment YZ. Now, within an isosceles triangle, we have two different types of angles. We have what's called a vertex angle and base angles. With this isosceles triangle, the vertex angle is going to be the angle that's between the two congruent sides. So here, the vertex angle is angle X. Well, the base angles are the other two angles right here, angle Y and angle Z. So angle Y and angle Z are what we call the base angles. Now that we're familiar with the components of an isosceles triangle, we can now do other problems that relate to isosceles triangles. For example, let's look at exercise 5. Here it's asking us to find the measure of segment AB and the segment BC. So since this is an isosceles triangle, we have to be careful with the terminology used. Here it says that triangle ABC has A as its vertex angle. Now let's look back at what the vertex angle told us. The vertex angle of an isosceles triangle is the angle that's between the two congruent sides. So what I want us to get into the habit of doing is putting the same amount of slashes through the two congruent sides. And again, we know that these are the two congruent sides since they told us that angle A is the vertex angle. Now, we can set up an equation to find the value of X, and then, of course, answer the question. They want us to find AB and BC. So let's start off with writing an equation. We know that since AB is congruent to AC, that means that 5x minus 7 is equal to 23. And let's go through our steps for solving for x in an equation. We want to isolate this variable x by bringing these two values, the 5 and the 7, to the right side of our equation. So I'm going to add 7 to both sides to cancel those two values. I then get that 5x is equal to 30. And again, we want to isolate x. Since 5 is attached to our x by multiplication, let's divide both sides by 5. Now, I end up with x is equal to 6. So what we've done so far is we've found the value of x, and that's going to help us to answer the question. But let's look at what they're asking us to do. We want to find the measure of AB right here. So let's use proper notation. Remember, segment length is given with the notation of a segment without the bar above it. So the length of AB is given as 5x minus 7 in terms of x, and now we'll substitute the value of 6 in for x right here. So we end up with 5 times 6 minus 7, which gives us 30 minus 7 for a grand total of 23, which actually we already knew, and since we found the value of x, this helps us to check that we found the correct value of x. Now let's find the value of the length of BC. Again, BC is equal to 3x minus 5. So let's plug our value of 6 in. For x and solve algebraically. So 3 times 6 minus 5. Using our order of operations, we know that 3 times 6 is 18. Minus 5, we end up with 13. So we've now completely answered the question. We know that BC has a length of 13. And again, AB we already knew was equal to 23, but we verified that our value of x was correct. Now that we know how to classify triangles by their angles and their sides, and some review of terminology for an isosceles triangle, and applying algebraic examples, this concludes our lesson on classifying triangles.
Made with Doodlecast Pro.